Lesson 81 problems. Okay, let's do problems 1, 2, 3, 4, 6, 7, which are today's, 10, 11, 12, 16, 17, 21, 22, 24, 28, and 29. Okay, number 1. Monkeys varied directly as turtles squared. When there were 2 turtles, there were 100 monkeys. How many monkeys were there when there were 5 turtles? Work the problem once using the direct variation method and again using the equal ratio method. I'm not going to make you work it both ways. You can pick which method you want to use. I personally prefer the equal ratio method. So because they vary directly, we have monkeys 1 over monkeys 2 equals turtles 1, let's see, as turtles squared, which is going to be squared over turtles 2 squared. And then you just need to plug in your numbers and solve for this. So monkeys 1 was 100. How many monkeys were there? So we don't know. Monkeys 2. Turtles 2 is 2, and it's squared over turtles 2 is 5 squared. So you need to solve for M2. Number 2, the number of macaws varied inversely as the number of apes squared. When there were 4 macaws, there were 10 apes. How many macaws were there when there were only 2 apes? Same thing, you can choose which method you want to do. So if you want to solve for K, you can. I'm going to use the ratio method, which is macaws 1 as over M2. And then remember, when it's inverse, then we flip-flop. So we have A2, apes 2, over apes 1. It's the number of apes squared. These are squared. Okay, so then you're just going to put in your numbers. So make sure you're putting in the first monkeys. Make sure you're putting in the second monkeys. Make sure you're putting in, let's see, they're asking for how many macaws. So this is what you're going to be solving for. Make sure you don't forget the squared part of both of these. Okay, and solve for M2. Number 3, Roger made the 375-mile trip in 10 hours less than it took Judy. This was because he traveled 3 times as fast as Judy traveled. How fast did each travel, and for how long did each travel? Okay, so they've given us his distance. So the rate of Roger times the time of Roger equals 375. And then he made the 375-mile trip in 10 hours less than it took Judy. This is implying that their distances are equal. So that means the rate of Judy times the time of Judy also equals 375. Okay, then we have time. So the time of Roger equals the time of Judy minus 10, because he did it in 10 hours less. And then he traveled 3 times as fast. So the rate of Roger equals 3 times the rate of Judy. Okay, this is the problem where you need to plug things in. So I have TR and RR, so lots of substitutions to solve for all the things. TR and RR, which I would then plug into this. So 3RJ times TJ minus 10 equals 375. So that means 3RJTJ, which RJTJ equals 375. So 3 times 375 minus 30RJ equals 375. Make sure I'm not cutting off. Okay, you need to do the math of this, solve for R of J, plug it in. I'd probably plug it into here, solve for R of R, then just start plugging things in so that, let's see, how far did each travel and for how long? So they are wanting you to solve for all of the things. Okay, number 4. Whittle-Cootie has one solution that is 10% glycol and another that is 40% glycol. How much of each should she use to get 200 liters of solution that is 19% glycol? Okay. So first of all, I'm going to write down here, this is just how I usually organize, my P equals 10% and my D equals 40%. Now, my first equation, if I put together P plus D, I'm going to get 200 liters. Now, my second equation needs to involve the percentages. So let's see, I labeled P as 10%. So turn it into a decimal, 0.10 P, because I don't need a parentheses, plus 0.4 D equals, and it says they want it to be 19% of the 200, okay? So now you're just going to solve for this, like 0.19 times 200. You need to make this equation say P equals or D equals, and then substitute it in here for here. Solve for whichever one, plug it in up here, solve for the other one, and then your answer needs to say 10% equals 40% equals whatever you get. And your answer then will be in liters. Okay. All right, number 6. All right, these are today's, which I feel like should not be too hard because you've already done multiplying by the conjugate with square roots, and I think those are harder than multiplying by these i's. So conjugate, opposite sign, whatever we do to the bottom, we have to do to the top. You're going to FOIL. First times first is 6. Outer, minus 5i minus 2i, so it gives us minus 7i. And then we're just adding those, so we only have I. Now we're multiplying, so negative 1 times negative 5 is plus 5i squared, but I squared is negative 1, so 5 times negative 1, so I'm going to erase that and switch it to negative 5. Then down here, first times first, 2 times 2 is 4, outer plus inner will cancel. 5 times negative 5 is negative 25 I squared is negative 1, so I change it to plus 25. And I have 1 minus 7i over 29, but this is not my final answer. Remember, it's not in standard form, so I've got to separate it out into 1/29 minus 7/29 I, and that would be your final answer. Okay. Try number 7 on your own. There shouldn't be anything crazy that comes up. Following the same thing, you're multiplying the bottom by the conjugate. Whatever you do to the bottom, do to the top. Number 10. All right, the square root of P minus 48 equals 12 minus the square root of P. And they have kindly already isolated it, so this is all by itself over here. So I'm going to square both sides. Instead of writing squared, I like to rewrite it out because when I'm foiling, I think it's easier to see my first, my last, my outer, my inner, and my last. Okay, so squaring a square root gets rid of that. P minus 48 equals 12 times 12 is 144. 12 times -1, -12 times the square root of p, times -12 times the square root of p, so negative times a negative, so plus 144 in the, let's see, p, no, adding those, 144 times the square root of p, and then -1 times -1 positive, square root of p times the square root of p cancels out, so plus p. Looking back at my problem here. Oh, sorry, I thought that seemed weird there in the middle. I multiplied those when they were needed to be added. So -12 minus -12 gives us -24. I was ahead of myself here on the multiplying. Okay, now we want to move this 144 over here in this p. So minus p is going to get rid of p's on both sides. Minus 144. 144 plus 48. So we have 192 equals -24 times the square root of p. I'm trying to get the square root of p by itself. So I'm going to divide both sides by -24. And the square root of p equals 8. I got to square both sides to get p by itself, okay? Then you need to go back and check, does this work? Well, this isn't my original problem, but you go back and double check that 64 works here in the original problem. 64 minus 48. 16, square root of 16 is 4. 4 equals 12 minus the square root of 64, so 12 minus 8 is 4. 4 equals 4. Yes, that will work. Okay, number 11. You should be able to do this. You need to, the first thing, it's 3 variables. You need to get one to say it equals something. So I would say y equals 3z, okay? Now, go back in your first one, x plus, and plug everywhere that has a y, write 3z instead. And then use either substitution or elimination to solve for either x or z, because those are the 2 variables you're going to have. Then plug it into your equation, solve for y. But it's mainly getting that first one and substituting that in to solve for the rest. Okay, number 12. The 2 forces act on a point as shown. Find the resultant force. I know these are really long and painful, but that's why I didn't give you quite as many problems today. So I'm just going to get you started on this. Okay, so this is 71. So I can make this a right triangle. And 8, let's see, this is 8. And straight up is 5. Okay, so this is your u, this is your r. You need to use, here's your hypotenuse, so sine equals u over 8, solve for u, and then cosine of 71 equals r over 8. Okay, that's your first step. Then we're going to use, this is just straight up on here, so we're actually not drawing a triangle. So whatever you got for u and r for these, then you're going to add, we're going up 5.0u plus to the right or left 0, so 0.0r. You're going to add that, okay? Now, once you get the answer to that, okay, I'm glancing here at the answer book because I didn't actually do the math for this. So then you're going to have, I'm going to draw a different grid here. You have 2.6r Okay, so I'm thinking of this as 2.6r, and then 2.6, and then 12.56u. Sorry, the r is not positive. I have to redraw my quadrant. Okay, so I have negative 2.6 and then positive 12.56. Okay, so I need my hypotenuse here, and I don't have my angle. So this is where tangent comes in, opposite over adjacent, and you're looking for an angle. So you need to punch in second tangent into your calculator, 12.56 divided by 2.6. That's going to give you a degree. Okay, and then to solve for h, you use your Pythagorean theorem. So a squared plus b squared equals c squared, then take the square root. Okay, so then your answer is whatever you get for h at the angle, whatever your tangent degree was, and that will be your answer. All right, 16. 1 plus the square root of 2 over 3 minus the square root of 2. This is where you're multiplying by the conjugate. Whatever we do to the bottom, we need to do to the top. So you need to do outer, and then, or sorry, first times first, and then outer plus inner, and then last times last, which will get rid of your square roots, and you'll just have 2. Down here, you're basically just doing first times last, because outer plus inner cancels out. Okay, and then let me just make sure you don't have an I or anything. Yeah. Okay, yep, so go ahead and solve for that one. 16. All right, 17. Okay. In order to solve for x, you are going to take this arc plus this arc divided by 2 gives you x. And then for y, when it's on the outside, you take the outer arc minus the inner arc and divide that by 2 to get your y. So 17, 21. Okay, for 21, we've been working on these lately. You need to multiply, let's see, it looks like down here, all of these you're going to multiply by 100. That's the furthest out the fraction goes. That'll turn those all into whole numbers. 15x plus 1y equals 84. Up here, common denominator, which it looks like your common denominator is 3. So you're just going to end up with 2x minus 1y equals 18. And then you can use elimination or substitution to solve for those. 22, using the quadratic formula, you need to get it set up in the right format. Minus 3x minus 2 equals 0. This is where you have your a equals, your b equals, and your c equals. And trying to think what page I told you that formula was on. Let's see if I can find it quick. Lesson 71. I think it's 298. Page 298. Use that formula, okay? So a equals negative 2. Just double checking a few things here. Yeah. A equals negative 2, B equals negative 3, C equals negative 2. Use that formula and solve. 24. Find x and y. Okay, you're using the similar 45-45 triangles, okay, which is 1 square root of 2. So that means in this triangle, you're figuring out your sliding factor, which is this times this. So your, scale factor, I a lot of times say that wrong for some reason, is this, and I said that backwards too, this times what? times your scale factor gives you 17. So what do I need to multiply this by to get this? What do I need to multiply this by to get this? Well, I have to use this and this because those are my only knowns. Well, to get scale factor by itself, I got to divide by the square root of 2. Well, I can't ever have a square root on the bottom, so using the tools I know, I got to multiply the bottom by the square root of 2 to get rid of the square root, but whatever I do to the bottom, I have to do to the top. So now using that, figure out what's your scale factor, and then it's super easy because these are both 1. So that basically just gives you the answer for x and y. All right, 28, you should be able to do. Remember that anything to the 0 power is 1, except when it's minus, make sure you're doing -1, not just pretending it isn't there. And then 29, find the distance. Okay, you should be taking y minus y, so -3 minus 8, and 5 minus -2. And then this squared plus this squared equals c squared. You're using Pythagorean theorem and take the square root of whatever these two are. That'll give you the answer. All right, that's it for lesson 81 problems.